Today we're going to practice adding fractions with unlike denominators. The first thing you have to do when adding fractions is to look at your denominators. If the denominators are not the same, you cannot add or subtract them. Let's look at our denominators here in our problem. 1/4 plus 3/8. 4 and 8. No way. You must make the denominators the same. You can do this by finding the LCM. Let's look at what LCM stands for. L stands for least. C stands for common. And M stands for multiple. Okay, least means the smallest number. So I'm going to jot that down just as a little mental note. Common means the number that they have the same. And multiple means we're going to list out our multiples. Let's look at our denominators again, 4 and 8. We need to find the LCM of these two denominators. So the easiest way to do this is to create a list. And I'm going to make my list here, 4 and 8. And we're going to list the multiples going across. Let's start with 4. 4, 8, 12, 16. I'm going to stop there. 8, 8, 16, 24. Looking at our multiples, we can see that 8 is the least common. 16 is also a common multiple, but it's not the least. So we're going to use 8. Now, we need to find an equivalent fraction for each, using the LCM as the new denominator. Remember, our LCM is 8, so I can write that in to our denominator for our new fractions here. Remember, we need to show our work, and the golden rule of fractions helps us to do that. How do we get from 4 to 8? We multiply by 2. And the golden rule of fractions says whatever we do to the denominator, we have to do to the numerator. So I'm going to multiply by 2 up here. And when I multiply 1 times 2, I get 2. How do I get from 8 to 8? Well, that's the same number. What I'm really doing, though, is multiplying by 1. And I want to show my work because that's keeping good practice. So 3 times 1 equals 3. Let's draw a picture just to make sure. We have two models, 1/4, and I want it to show that it equals to 2/8. So in our first model, I'm going to break it into fourths and shade in one of those fourths. My second model, I want to show 2/8. So I keep my lines pretty much the same, fourths, and then divide it one more time to show eighths. And I need to fill in 2 of those. You can see that they're the same. So I did a good job. Here are my two new fractions. 1/4 equals 2/8, and 3/8 stays the same. It equals 3/8. Finally, we can add the numerators. Remember, the denominators stay the same. Here's my new problem. 2/8 plus 3/8. This is how the problem would look if I showed all of my work. 1/4 equals 2/8, 3/8 equals 3/8. I have my original fractions, I have my work, and I have my new fractions. Now all I have to do is add my numerators. 2 plus 3 equals 5. Remember, my denominator stays the same. 5/8 is my answer, but first I have to make sure that my answer is written in simplest form. Can 5/8 be reduced? No, it can't. It's as small as it can go. So I am good. 5/8 is my final answer. Let's do one more problem just to practice and make sure we are good with adding fractions. I have 2/5 plus 1/3. Remember, the first thing I need to do is check my denominators. 5 and 3 are different, so I need to find my LCM. I'm going to start by writing my lists. I have 5 here. Let's start with my multiples of 5. 5, 10, 15, and as soon as you recognize a multiple of my second number, I can stop. 3, 6, 9, 12, and I have 15. There's my LCM. So I can go ahead and write 15 as my new denominator. Let's extend this line just to make everything neat. How do I get from 5 to 15? I multiply by 3. And my golden rule says that I have to do the same to the numerator. Times 3. 2 times 3 equals 6. How do I get from 3 to 15? I multiply by 5. Again, my golden rule, I have to do the same to my numerator. 1 times 5 equals 5. Now all I have to do is add my numerators. 6 plus 5 equals 11, and my denominators stay the same. Check to make sure your answer is in lowest terms. 11/15 can't be reduced, so I'm done.